Today we're going to be going over the Physical and Chemical Changes Lab for Clear Horizons Early College High School. The first thing you want to remember is that everyone in lab has a job. We have a safety supervisor, which is very important to read the MSDSs and make sure everyone's wearing the proper PPE. Materials manager ensures that the station is clean and washed and dried and put back. The procedure pilot follows all the procedures. And the on-task officer, if you have one, is to make sure everybody is staying on task. Each person wears a badge. It's very important that you wear the badge while you're in the lab so that we know what your job is. Okay, let's go to our first station, Station A. Station A, we're going to add sodium hypochlorite, which is bleach, and phenolphthalein. So the safety supervisor makes sure that we've read the MSDS so that we can wear the proper PPE. For this particular station, you need goggles and gloves and a lab apron. Make sure it's a chemical lab apron. Okay, here's the MSDS for the phenolphthalein solution. It tells you your first aid measures, the wear of the chemical goggles and gloves and the apron. And on the back it tells you how to dispose of it and what would happen. Here's the MSDS for the bleach or sodium hypochlorite, which also tells you the first aid measures, PPE, how to handle it, and then how to dispose of it. Always check your MSDS. Okay, here are the materials for the station. You have bleach and phenolphthalein. So what you're going to do is it tells you in the procedure that you're going to take a whole squirt of bleach. And so you're going to use pipette and fill it, and you put it in the tray. You can see it's kind of a yellowish solution, but clear, so it's not cloudy. Always put your caps back on your materials when you're not using them. Then the next step tells you to take your phenolphthalein and add 2 or 3 drops. So look carefully, and you notice that there's a color change. Now color changes can be physical or chemical. In this case, you would not expect something that's yellow with something that's colorless to turn into something that's purple. So record your results in your lab notebook. Afterwards, you would dispose of it properly. Station B is sodium bicarbonate, which is Alka-Seltzer, added to water. The safety supervisor tells you that you do need to wear your proper PPE, your goggles, apron, and gloves. The procedure pilot would make sure that you follow all the procedures. First, it asks you to put 200 milliliters into a beaker of regular water. Then you're going to take 1 tablet and add the tablet to the beaker. Observe your results. If you'll notice, you took a liquid and a solid, and now you have bubbles, which indicates that there's a gas. So now you record your results, your observations, and determine if this is a physical or chemical change. Be sure to wash and dry the beaker when you leave the station. The next station is Station C. Station C is adding ammonium nitrate and warm distilled water. The safety supervisor tells you that you do need all your proper PPE at this station as well. Your procedure pilot will let you know what to do. The first thing is you add 10 milliliters of warm water. So I have 10 milliliters in a graduated cylinder. I've already measured it out. You add it to a test tube. Be careful. Okay. It helps if you take your hand and warm the water a little bit more in the test tube. Just don't break it. Then it tells you to add 1 scopula of ammonium nitrate. I've already pre-measured that, which is just you scoop it in there. It's not a real measure. Now normally I would do this over a trash can, but I only have 1 hand. So, whoops, I'll clean those up. Okay. Now you take your glass stirring rod and you just kind of stir up the mixture. You would clean the stirring rod and wash it and dry it. Now when you touch the solution, I know you can't see it on video, but it becomes very cold. So you can determine if that's a chemical or physical change to go from room temperature to cold. This is actually the materials used in cold packs, like in your first aid kits. Station D. Station D tells you that you're going to observe a candle. You don't need any PPE, just don't burn anything but the candle. So here's our candle. I'm going to light the candle. Well, maybe you will. Okay. So here's our candle, and you observe the candle burning. There's a couple of different things to observe while you're watching this. The first thing is that the wick is clearly turning a different color and there's a flame. But the second thing that might not be as noticeable on camera is that the wax, which used to be solid, is now turning to a liquid. So there's a few things going on here. When you record your results, be sure to make sure you include both of those observations. When you're finished, be sure to blow out the candle. Station E is food coloring in water. No PPE is required here. You have about 150 milliliters of water in the Erlenmeyer flask. And then you're going to add a couple of drops of one food coloring. In this case, I'm using red. First, you're going to observe it before you swirl. So observe how the food coloring is dispersing into the water, dissolving into the water. So that's your first observation. Then you're going to swirl the Erlenmeyer flask and then make the observation after the swirl. Now you're going to add a couple of drops of a different food coloring, in this case yellow. It's kind of hard to tell. I'll add a few more drops. Okay. I don't know if you can tell, but it's just dissolving. And then swirl. If you saw there was some yellow. The contrast is not as strong here. It becomes a little more orange, so if you would expect red and yellow to become more orange, then that's a physical change. But if it's unexpected, then it would be a chemical change. Let's go to Station F. Station F is acetic acid or vinegar added to milk. Your safety supervisor will tell you that you do need to wear PPE here because you are using an acid. So it tells you to take 5 or 6 pipettes of milk. And so we're going to add the pipettes of milk to the dish. All right. Make your observations of the milk. A couple bubbles because of the air. But now you're going to add 3 or 4 pipettes of vinegar or acetic acid. So you're adding a white mixture to a clear, or a white solution to a clear solution. You would kind of expect it to be a little more dilute. And then it asks you to swirl. And it asks you to tilt the dish so you can see what's on the sides of the dish. As you can tell, you took 2 liquids and you made some solids. And you can also see some solids kind of floating around in the mixture. Now determine if it's a physical or chemical change, and then record it in your lab notebook. Be sure to clean afterwards and wash and dry all glassware. And put the lids back on your chemicals. Okay, now we're going to go to Station G. Station G is observing intensive and extensive properties. So you're going to observe 2 samples of aluminum, and one is larger, one is smaller. So you have a larger sample of aluminum, and then you have a smaller sample of aluminum. You're going to fill out your table with the variety of properties. In page 752 of your textbook, it has several properties of aluminum highlighted here in yellow. It has its melting point, its boiling point, its density, regardless of the mass. One of the properties you're recording is the mass. So you have a larger sample of aluminum, and if you'll look at this triple beam balance, the mass has 10 grams plus 14 grams. And if you read with the right significant digits, it's 14, and then there's already scales for, or markings for 0.7, and it's almost at 14.8. So you would record in your lab book 14.7, possibly 78 or something like that. For the smaller sample, you would record the mass, which is already on here. There's no tens. The mass is approximately 0.23 or 0.24 grams. Another thing it asks you to do is measure the volume. Well, we know volume is length times width times height. So you would take your centimeter ruler and measure the length, which is about 7.5, the width, which is about 3.5, and then the height, I've already previously measured, is about 0.3. So you would put those in your calculator and you would determine the volume. Here, you would use, and these are in cubic centimeters, you would use about 2.5 by 2.5, and then the height is a little less than 0.1, so maybe 0.05. So if you put those in your calculator, you'll get the total volume of this one. And congratulations, you have completed the Physical and Chemical Changes Lab for Clear Horizons Early College High School. Record all your observations, and also don't forget to answer your post-lab questions.